Good day, everybody. How are you all? Today we are going to talk about confidence intervals for the mean and confidence interval for the population standard deviation. So let me share my computer screen with you. Says the following data on cost of repair in dollar of a part for a machine are available. 30, 35, 19, 23, 27, 22, 26, and 16. If appropriate, construct a 98% confidence interval for the mean cost of repair. And part B, if appropriate, construct a 95% confidence interval for the population standard deviation. So, part A, since sample size is less than 30, we have to determine whether the sample came from a normal population. The easy way to do it, do a modified box plot for the data. Modified box plot for the data and check for outliers. If there is any outlier, then the sample did not come from a normal population. If it did not come from a normal population, then we cannot construct the 98% confidence interval. So we use TI-84. So the first thing is second button, then the plus button, which is on top of the enter button on the bottom right corner of the calculator. Then select number 4, which will put clear all list on our calculator screen. And then hit enter, and it says done. That means we have cleared the memories of the calculator. After that step, after clearing the memories of the calculator, then we will press stat again, not just this time, stat, and then number 1, which is edit. And this will allow us to enter data in L1. L stands for list 1. Data in L1. Okay, so let's do it. So press the second button on the top left corner of the calculator, then the plus button on the bottom right corner of the calculator on top of the enter button on the bottom right. So second plus and then 4. I get clear all list on the calculator screen, hit enter, done. That means memories have been cleared. Now stat and 1, enter the data in L1, which is 30, then 35, then 19, then 23, then 27, then 22, then 26, and 16. Okay. So we have 8 data points. So definitely we need to prove that this sample came from a normal population. The easy way to do that is then we will press the second button after entering the data. After entering data in L1, press second button on the top left, and then Y equal to key on top of it. Second button and then Y equal to key. Okay, so if I move up a little bit, up a little bit. Okay, so I press the second and y equal to, then I select number 1. Okay, first line it should be on, the cursor should be blinking on, and then in the second line type it should be on 1, 2, 3, and the fourth type of chart, which is a modified box plot. So bring the cursor in the second line type to the fourth type of chart and hit enter so that it's blinking on the fourth type of chart. Okay, and then we will press zoom button, which is in the top row, third key on the extreme top row. Zoom and 9. Zoom and then number 9. Zoom and 9. And we see a box plot like this on our calculator screen. So the area in the center is the box. The two boundaries of the box are Q1, first quartile, and third quartile. And the vertical line in the middle is the median or Q2. The left whisker points to the minimum, and the right whisker points to the maximum. Notice, neither is there a square block on the right, nor there is a square block on the left. These square blocks indicate outlier. So no outlier. So no outlier in this data. So basically no outlier. No outlier. Okay. No outlier. This is important because had there been an outlier, then the sample did not come from a normal population. Then we will construct a 98% confidence interval, construct 98% confidence interval for the confidence interval for the mean cost of return for mean. How do I do that? Of course, I will use a calculator. So I will press the stat button, then highlight the test on the top row. Highlight means move the cursor on test and press the enter sign. So this cursor should be sitting on stats. And now we are going down to T interval. Going down, scroll down to T interval. Why T? Because the population standard deviation is not known. We cannot use a Z interval. We have to use the T interval, which is 8 option 8, T interval. Okay, so if I move up a little bit more, in T interval, our input should be on first line, should be on data. So bring the cursor on data and hit enter so that it's flashing us, blinking on top of data. My list is already set at L1 where I entered the data, so it's fine, do not change it. Frequency is already set at 1, do not change it. And C level is 0.98. Make sure it is 0.98, not 0.95, 0.98. And we calculate. Okay, so moving up a little bit. Next is bring the cursor on calculate. So move the cursor on calculate. Calculate and hit enter. Move the cursor on calculate and hit enter. So the 98% confidence interval for the mean is okay, between 18.3 and 31.20. 18.30. I rounded it to 2 places of decimal, and 31.20. What does it mean? With 98% confidence, we can state that the population mean will fall between 18.30 and 31.20. Okay, so this is the answer for part A. Okay, now I will summarize everything at the end, so do not quit right away. So let me go back to the top and see what is part B. So part B says, if appropriate, construct a 95% confidence interval for the population standard deviation. So 95% confidence interval for the population standard deviation if it is appropriate. So what do they mean by if it is appropriate? So part B, 95% confidence interval for population standard deviation. Standard deviation. Okay. So let me move a little bit further up. We have already shown from the scene, from the box plot. Box plot. There is no outlier. There is no outlier. Hence, the sample came from a normal population. Came from a normal population. Thus, we can construct the 95% confidence interval for the population standard deviation. Interval for the standard deviation, for the population standard deviation. Remember, standard deviation gives you an average variation of a number in the data set from the mean. Okay. So first we had to prove that the sample came from a normal population, which we did by constructing the box plot and showing or observing that there are no outliers either on the left or on the right. Okay. Now to construct the confidence interval for the population standard deviation, we need degrees of freedom. Degrees of freedom of the sample. Is given by df is equal to n minus 1. My n was 8. 8 minus 1 is 7. This is important because that will help us to identify correctly the critical values of chi-square, which we will need in constructing the 95% confidence interval for the population standard deviation. So let's move up a little bit. So we need the chi-square distribution. we will use chi-square, chi, pronounced as chi-square, distribution with 7 degrees of freedom. With 7 degrees of freedom. Okay. So the chi-square distribution will look like this. This is chi-square, and it will look like this with an extended tail on the right. Okay. So the area in the center, much like the confidence interval for the mean, is 0.95. So area in the center is equal to confidence level is equal to 0.95. So area in two tails is 1 minus. Why 1? Because total area under the curve is 1, from which you subtract the area in the center, you're left with 0.05. So area in each tail is 0.05 divided, this is 0.05, right? Divided by 2 is 0.025. So, okay, this is also 0.25. Now, in terms of symbol, this is your C level is 0.95. That's your confidence level. And alpha is equal to 1 minus C is area in two tails, is 1 minus 0.95 is 0.05. So area in each tail is divided by 2 is 0.05. Okay. So this area is alpha by 2 is 0.025, and this area is also alpha by 2. The chi-square, the critical values of chi-square are this and this. However, they're indicated by the area to the right of it. So this chi-square will be indicated by the area to the right of it. Remember, the area in the left tail is 0.025. So area to the right of it is chi-square 1 minus 0.025. Or this will be chi-square 0.975. That is this critical value. So let me move up a little bit more, and I will do the right critical value. So the left critical value in this case, is chi-square 0 is indicated by chi-square 0.975 because the area in the left tail is 0.025. So area to the right of this critical value is 1 minus 0.025, which is 0.975. Okay. How about the critical value on the right? So let's do it this way. So I will first erase this arrow over here. Okay. And I will definitely draw another arrow to indicate that critical value. So that is the critical value. So what is the area to the right of it? Remember, chi-squares are indicated by the area to the right of it. Is the area in the right tail, which is 0.05, divided by 2. So this is chi-squared 0.025. For this particular curve, degrees of freedom is, remember, 8 minus 1 is 7. So we need to find out chi-square 0.975 and chi-square 0.025 for degrees of freedom equal to 7. How will I do that? I have to look up in the table. So for a minute, I will stop sharing my board and I will go to the critical value table. So give me a minute and let me find out the table for you. Okay, so I will share it with you. So this is my chi-square table. Notice in the top, I have chi-square 0.995, 0.990, etc. And degrees of freedom in the first column. My degrees of freedom is 7. So I'll have to draw a horizontal line through 7. And then I'm looking for chi-square 0.975, which is the third column. So third column and 7. Third column and 7 degrees of freedom is 1.6. 0.975 is 1. So I'm making a note of it in another piece of paper. So chi-square 0.975, this will be my left critical value for 7 degrees of freedom, is equal to intersection of the horizontal line through 7 and the vertical line through chi-square 0.975 is 1.69. Okay. Similarly, I will draw a horizontal line through 7 degrees of freedom in the first column and a vertical line through chi-square 0.025, okay, 0.025. So that is the third column from the right, So 7 and intersection of chi-square 0, vertical line through chi-square 0.025, that is 16.013. So 0.025, I draw a vertical line through chi-square 0.025, intersection with the horizontal line drawn through 7 degrees of freedom, and that value is chi-square 0.025 and degrees of freedom 7 is 16.013. 7 degrees of freedom. Okay. So now I'll go back to the table. Okay. I go back to doing the problem. Okay. So, okay. Let me see where is my, here it is. Okay. Okay. So let me write those critical values, which I found from the table. So chi-square 0.975, which is the value, critical value on the left, is equal to 1.69, and chi-square 0.025, which is the critical value on the right, is 16.013. Okay, so now we are ready to construct the 95% confidence interval. How to do that? So the formula for the 95% confidence interval, we'll start with the variance. So 95% confidence interval for the variance interval for the variance is n minus 1 times s square, okay, divided by, okay, chi square, in this case, chi square alpha by 2 less than sigma square, which is the variance, population variance, less than n minus 1 s square divided by chi square 0.975. Okay, or let me write it in chi-square term, chi-square 1. So it is chi-square 1 minus alpha by 2. So if I plug in the value n minus 1 degrees of freedom is 7, I have to calculate the s. So how do I do that? I press this. Oh, it's in front of me in my screen. SX calculator screen. The sample standard deviation is 6.09, you might say, and then you square it, divided by chi-square alpha by 2. Okay, chi-square alpha by 2 is 16.013 less than sigma square less than 7 times 6.09 square divided by chi-square 1 minus alpha by 2, which in this case is 16.0, I'm sorry, 1.69. So, pardon my mistake, is 1 point, so this is 1.69. Okay, this is chi-square 1 minus alpha by 2, and this is chi-square alpha by 2. Okay, so this is 1.69. Okay, so if I move up a little bit and do the calculation, so it is 7, then left parenthesis 6.09, right parenthesis x squared divided by 16.013, and that is equal to 16.213 less than sigma square less than, again, 7, then in parenthesis 6.09, right parenthesis x squared divided by 1.69, and the value is 153.619. Then we will take square root on all of the quantities. Okay, so square root means second, x square is a square root. The first number is 16.213. So this is 4 point, let's see, 4.03 less than sigma less than second x square is square root 153.619, which is 12.39. So what is the conclusion? If I create some more space, so with 95% confidence, we can state that the actual population standard deviation, that the actual population standard deviation will fall between 4.03 and 12.39. So, before you leave, let me summarize what I did. So, let's first move up to the first part of the problem. So, we have been given 8 repair costs. We are required to find a 98% confidence interval for the mean. Since the sample size is less than 30, we have to prove that the sample came from a normal population. This is done by constructing a modified box plot using second y equal to the number 1. Then for the type of chart, we select the fourth type of chart, which is the modified box plot. And the modified box plot shows there is no outlier either on the left or on the right. Hence, the sample came from a normal population. And then we calculate a 98% confidence interval for the mean using T interval. We use T interval because we do not know the population standard deviation. Okay. In this case, T interval, our input, stat test and T interval, our input should be data. And our C level is 0.98. When we do that, we get the 98% confidence interval as between 18.30 and 31.20. Now, in the second part, they said, if appropriate, construct a 95% confidence interval for the population standard deviation. Why did they say if appropriate? Again, because the sample size is 8, which is much less than 30, we had to prove that the sample came from a normal population, which we already did as part of part A of the problem. Okay, so we did a modified box plot and there was no outlier. Okay, and the sample came from a normal population, thus we can construct the 95% confidence interval for the population standard deviation. Now we need the degrees of freedom of the sample, which is sample size -1, 8 minus 1 is 7. So I show you the chi-square curve. Each chi-square curve has a different degrees of freedom. This one has degrees of freedom is 7. Area in the center where we want the confidence level is 0.95. Area in the left tail is half of 0.05, which is 0.025. Area in the right tail is 0.0252. But the peculiarity or oddity of this chi-square curve, the critical values on the left tail and on the right tail are indicated by the area to the right. So for the left tail, area in the left tail is 0.025. So what is left on the under the curve to the right of this critical value area-wise is 1 minus 0.025, which is 0.975. Hence, the left critical value will be indicated by chi-square 0.975. And the right critical value, the area in the right tail being 0.025, will be indicated by chi-square 0.025. Then we have to go to a chi-square table. The first column is degrees of freedom, okay, where our degrees of freedom is 7 because sample size is 8, 8 minus 1 is 7. And we find the two critical values. One on the left is chi-square 0.975. One on the right is chi-square 0.025. These chi-square are labeled on the top row of the table. Degrees of freedom is in the first column. So you locate 7 degrees of freedom in the first column, then draw a horizontal line through 7 and find the intersection of the vertical lines drawn through chi-square 0.975 and chi-square 0.025. Hence, we locate chi-square 0.975 as 1.69 and chi-square 0.025 as 16.013. Then we plug it in the formula for the confidence interval for the variance. Okay, variance is the square of the standard deviation. Okay, so this is given by n minus 1 s squared divided by chi-square alpha by 2 less than sigma square less than n minus 1 s squared divided by chi-square 1 minus alpha by 2. Okay, so be careful. Chi-square alpha by 2 is the large number which goes in the left boundary. So it is 7 n minus 1 is 7 times sample standard deviation squared, 7 times 6.09 squared divided by chi-square alpha by 2, which is the critical value on the right, which is 16.013. Similarly, the upper boundary is n minus 1 s squared divided by chi-square value on the left, which is 1.69, critical chi-square value on the left tail. Okay, if we do the calculation, we get the 95% confidence interval for the variance, and then you have to take the square root of all three of them to get the 95% confidence interval for the standard deviation. And after taking the square root, we can state with 95% confidence that the actual population standard deviation will fall between 4.03 and 12.39. I will stop here today. If you have any question or comment, write me a note. I'll get back to you as soon as possible. If you like this video, please give me a hearty thumbs up. I really appreciate that. I work hard to get all this material clearly done for you. If you have any question, any suggestion, write me a note. If you like this video, please share with your friends. You and your friends, please subscribe to my channel, Math Science Topia, and I solve all kinds of math problems in this channel. So please do not forget to visit me tomorrow when I'll come back with another problem, another solution. Thanks for watching. Have a nice day. Take care. See you next time. Please do not forget to visit me next time, okay? I have solutions for all kinds of problems. See you. Take care. Have a nice day.